Alright, so today let's solve this really interesting system of equations. We have x plus y equal to 10 and a product x times y equal to 12. We need to solve these equations for x and y, so if you have your assumption, your solution, you can also write it in the comments below and then we will check our answers. Okay, so let's use our basic method. First of all, from this first equation, let's express our y. Okay, let's do it. So our first step is to express our y from the first equation. So we have y equal to 10 minus x, okay, 10 minus x. And right now, we have the same y right here, but we can plug in this 10 minus x. So let's plug in, instead of this y to the second equation, let's plug in 10 minus x. So let's do it. So we have x from here, and instead of y, we plug in this expression. So 10 minus x equal to 12. Let's simplify this. Right now we have only one variable, so we can easily do this. First of all, let's multiply x by this parenthesis. So we have 10x minus x squared and equal to 12. Okay, right now let's change an order because it looks like this is a quadratic equation. Yeah, we have square, we have x, we have a constant, but we prefer a little bit different order. So let's change this order. First of all, let's write this minus x squared on the first position, minus x squared. Secondly, plus 10x. And third, we're gonna write this 12 on the left side, but with the negative sign. So minus 12 and equal to 0. And right now everything is great, but we don't like this negative sign right here. We don't like this minus. So that's why let's multiply both sides by minus 1. Okay, multiplying by minus 1. And right now we can easily change all the signs. We have x squared minus 10x and plus 12. And this is our final quadratic equation. So right now let's solve this quadratic equation. Of course, this is up to you. You can solve this instantly, but maybe a lot of students watch here this video. So right now I'm going to solve it with the basic method of coefficients. So a equal to 1. So the first coefficient equal to 1, second coefficient equal to minus 10. So b equal to minus 10. And c equal to 12. Okay, so c equal to 12. Right now we know everything, so we can easily start with our discriminant. So for example, let's find our discriminant. So b squared minus 4ac. This is our discriminant, and let's plug in everything into this spot. So b squared, we have minus 10 square, this is our b square, minus 4 times a times 1, and c equal to 12 from here. So our discriminant equal to 100, so minus 10 square equal to 100, minus 4 times 12 equal to 48, So right here our discriminant, 100 minus 48, is equal to 52. So our discriminant is positive. This is also really great for us. So we have two real number roots. Let's solve it for x first and x second. So our x first and x second equal to minus b plus minus square root of discriminant. This is all known formula, minus b plus minus square root of discriminant all over 2a. And right now let's plug in, we know everything, so let's plug in each of these elements into this spot. So we have minus b equal to minus 10, plus minus square root of 52, square root of discriminant, and all over 2a, 2 times 1 equal to. So minus 10 equals to 10, plus minus. What about this square root of 52? This 52 is not a good value in terms of, when we can find, when this is like a table case, like square root of 81, square root of 25. 52 is not a good constant, so we can't solve this part, so we can't evaluate it with our table case. So that's why let's split this 52 as 4 times 13. Okay, let's do it. So we have 4 times 13. all over 2. Okay, right now there is one really important property, square root property, so we can write this expression as 10 plus minus square root of 4 times square root of 13. Okay, we can split it, okay, over 2. And right now this square root of 4, we can easily evaluate this because this is our table case, so this is equal to 2. So we have 10 plus minus 2 square root of 13. We leave like that because this is not a table case, and this is like a prime number, I guess. Yeah, so all over 2. And the final step, let's factor 2 from our numerator. So what do we have as a result? We have 2, and in parentheses we have 5 plus minus square root of of 13 all over 2. And the final step, we're going to cancel these two. So our final answer, 5 plus minus square root of 13. So we have two numbers. So in the end, we have two pairs, x first, x second, and y first, and not like x first, y first, and x second, y second. Yeah. So that's why let's gather all of this information and write at this place. For example, at x first, let's write it with the positive sign. So 5 plus square root of 13. 5 plus square root of 13, and the second one, so x second, equal to 5 minus square root of 13. So 5 minus square root of 13. And right now we need to go back to the beginning. So where do we have our really important equation? So this one, y equal to 10 minus x, extremely important equation. And let's remember it and let's write it at this place. So y equal to 10 minus x. And right now let's find our pairs, x first, y first. That's why, for example, let's start with y first. So y first equal to 10 minus x first. So 10 minus x first. Let's plug in everything. So y first equal to 10 minus this expression, 5 plus square root of 13. Yeah, and y first equal to 10 minus 5 minus square root of 13. So right here, 10 minus 5 equal to 5. So our y first equal to 5 minus square root of 13. And you can see like a symmetry. Yeah, we have a symmetrical answers. Right here, 5 plus square root of 13. Right here, plus minus square root of 13. Yeah. So that's why it looks like y first will be absolutely the same. But let's check it. So we have y second equal to 10 minus x second. 10 minus x second. So y second equal to 10 minus x second, this one, 5 minus square root of 13. And yeah, we will have absolutely the same answer. So 10 minus 5 and plus square root of 13. So y second equal to 5 plus square root of 13. So we have our final answer to this question. And in the end, we will check it real quick. Okay, so I hope you understand this part. So let's write our final answer at this place and then we will check it. Okay, so our final answer to this question. So x first, y first, the first pair, so y first, and x first, these are our pairs. So we have 5 plus square root of 13, 5 minus square root of 13, really great. And right now the second pair, the same thing but with a different order of signs. So we have 5 minus square root of 13, this is our first, x second, yeah, and y second, 5 plus square root of 13. This is our answer to this question. And in the end, let's check it real quick. So let's write our question from the beginning. So x plus y equal to 10 and xy equal to 12. We have really great mathematical operations because x plus y is the same as y plus x. That's why we don't need to check both of these pairs. For example, let's check this one, okay? So 5 plus square root of 13, this is our x, plus y, but y equal to 5 minus square root of 13, equal to 10. As a result, we can cancel these square roots, so we have 5 plus 5 equal to 10. So first equation is great for us. We solved it, we plug in our root, and everything is great. And in the end, right now, let's plug in our right here at this place. Let's check multiplication. So that's why we will have 5 plus square root of 13, and I'm going to add one really important moment because addition and multiplication are really great mathematical operations because we can change an order. This is like 2 plus 3, this is the same as 3 plus 2, and absolutely the same thing right here. 4 times 3 is the same as 3 times 4. So we can easily choose one of these parentheses, for example, this parenthesis, yeah, with our answers. So 5 plus square root of 13, yeah, we're going to multiply by 5 minus square root of 13, and this one need to be equal to 12. And you know, a lot of students might be multiplying parentheses by parentheses, but this is a difference of squares, because when we have, for example, a square minus b square, this is equal to a minus b, a plus b, and we have absolutely the same case. Yeah, we have minus b, or we have different order. Yeah, we have plus minus right here, minus plus, doesn't matter. We have a plus b, a minus b. This is a difference of squares. So that's why right here we have 5 square minus square root of 13 square. As a result, this is equal to 25 minus 13 equal to equal to 12. So everything is great. Our answer is great and correct to this question. So I really hope you understand my solution. Also write your thoughts, write your response in the comments below. It will be really interesting to read about it. And I really hope you understand my solution. If you still have any question, write a question in the comments below. This is a basic math question. Easy, I would say easy math question. Tricky maybe in some way, but in general, a great and relaxing algebra question for everyone. So if you want to practice basic math, algebra skills, you can easily do this. We have a great quadratic equation. We have a great proof right here, so it's a great practice question for students to learn to remember different math aspects. Yeah, so thank you for your time. Have a great day. See you in the next videos. Also write your thoughts, write your response in the comments below. It will be really interesting to read about it. See you in the next videos. Have a great day.